Hi everyone! Today we're going to look more at piecewise functions. So I'd like to take a look at this model problem, and what I'd like to answer with you is this specific type of problem where essentially I give you a piecewise function, and if you don't have the graph, I'd like you to be able to answer the following questions. So for example, what is f of 1? What is f of 4? What is f of 4.1? So let's take a look. If I ask you, what is f of 1, then that means your input value is 1. Input is domain, so you have to look at your domain values here. And you have to see where does 1 fit. In other words, which interval is positive 1 given this function? Well, positive 1, since positive 1 is an input value, would go into this domain right here. Okay, that means your function that we would use is 3. That means your answer is 3. Your output is 3. Let's try this again. So this says f of 4. 4, again, is an input value. Input is domain. So you have to look at your domain values. Now, 4 shows up in two spots. 4 shows up here, and 4 shows up here. But only one of them is inclusive with the 4, and the one that is inclusive with the 4 is this one right here, so your output is 3. Okay, let's do this again. 4.1. So I have to look over here on your domains, and 4.1 actually would fit in here, so that means your output is -1. Let's take a look. 5.5. So I have to figure out where 5.5 fits. Okay, 5.5 would be in this domain area right here. So again, your output is -1. Let's look at 8. So 8's a little on the tricky side because 8 is in two spots, here and here, but you have to go where 8 is inclusive. So that would be in this part right here. So that is also -1. And now 10 would fit right here where x is greater than 8, so that means your output would be 0. Now just to give you an idea of what this would look like in terms of a graph, so this would be a nice review for you. It is 3 between 0 and 4. So between 0 and 4 it would be 3. So I would do an open circle right here at the 3. And at the 4 I would do a closed circle because it's inclusive at the 4. Then I would jump to -1 for 4, and that would be an open circle right here, all the way to 8, and that would be a closed circle at 8. And then it would be 0 for anything larger than 8, so I would do an open circle here, colored this way. So that would be my function. This would be a little bit easier for me to determine my answers looking at the graph, because this would say, for example, f of 1, that would be an input of 1. I would go up here at 1 and see that my output is 3. F of 4, I would go to 4 on the graph and I would go, okay, there's my output is at 3. 4.1 is just a little bit larger, so that would be right down here, and so on. Okay, let's try this again. Let's look at another model problem here. In this problem, let's see, we have 3 parts again, and our domain value for the first one would be 0. So I have to look and say, okay, of all of my domain areas here, where does 0 fit? Okay, well 0 shows up into two areas. It shows up here and it's in here. However, you got to go to where it's inclusive, and it's inclusive right here. So my function is x. So what I would do is I would type in, or I would put in f of 0 is equal to 0, which is 0. F of 7. Okay, let's try f of 7. f of 7 would be, let's see, 7 would fit in this domain area right here. So what I would do is I would input 7 into the function rule. So that would be negative 7 plus 1, giving me negative 6. Let's do f of negative 3. So I have to look and say, okay, where is negative 3? So again, negative 3 is an input value. That's domain. So negative 3 would be right here in this area right here. Your function is x. So f of negative 3 would just be negative 3. Okay, let's try this again. Okay, f of 4. So I have to look and say, okay, where is 4? Well, 4 seems to show up in two spots as an input value. It's here and here. However, it's only inclusive in one. So this would be the part that you use. So you would do f of 4 equals, we got negative x plus 1, so that would be negative 4 plus 1, which is negative 3. So your output is negative 3. So essentially what you're doing is you're looking to say, okay, where is the domain value? And then you're going to input that number into that part. Okay, so for example, 1. Go up here. 1 is in this area right here, so I will use that function rule. So f of x is equal to 3x. That's the function rule I'm going to use for this one. So f of 1 is equal to 3 times 1, which is 3. Uh-oh, and I'm missing one here. So let's make one up. Let's decide what we want to do here. Let's make this one f of, let's go f of 7. No, I have f of 7. How about f of 10? So we'll do f of 10. Okay, so we're going to go up here and we're going to say, okay, where does 10 fall is an input value. Let's look at our domain areas. 10 would be here, so that means I'm going to use this rule. I'm going to use the rule of f of x is equal to negative x plus 1. So f of 10 is equal to negative 10 plus 1, which is negative 9. And there you go. So my goal for you is to be able to answer these questions without the graph. Now, it is good reinforcement to show you how to graph this, so I think I will do that. So if I want to graph the first one, I'm only graphing it. So I've got f of x, but I'm only graphing it for values less than or equal to 0. So I'm going to do an input-output table, and I'm going to put in 0, and I'm going to put in numbers that are less, so negative 1, negative 2. If I input 0, I get out 0. I input negative 1, I get out negative 1. Input negative 2, I get out negative 2. So this would be a closed circle, closed because of the inequality symbol. Okay, let's do the next part. Let's do f of x is equal to 3x. And those are values between 0 and 4. So 0, I just need to pick another number here. Let's go 0, 2, and 4. I don't have to do all of them. So if I input 0, I get out 3 times 0, which is 0. Put in 2, I get out 3 times 2 is 6. And 4 times 3 is 12. There we go. Okay, so it's going to be an open circle here. So the cool thing is we've already got a dot there, so we don't have to worry about that. And then we have 2, 6. And then we have 4, 12. 12 is going to be off of my graph, and it will be an open circle, so I'll do the best that I can. There we go. And that is a very crooked line, but I know you guys can adjust. And I'll do my last one here, which is f of x equals negative x plus 1. and those are values that are greater than or equal to 4. So let's do 4, 5, and maybe even 6. So negative 4 plus 1 would be negative 3. 5, negate it and then add 1, would give you negative 4. 6, negate it and add 1, it gives you negative 5. So given this, let's see, at 4 I'd have a closed circle at negative 3. And 5, negative 4, and 6, negative 5, so yikes. That is a weird looking piecewise function, but it is a function and it does pass the vertical line test. And answering these questions that I answered would probably be a lot easier using the graph than it would be just using the function. But let's see. Okay, so I'm going to have you try this one. I will model the first two for you, and then I'm going to have you pause the video. So once again, 8. I have to look here and I have to say, okay, 8 is an input value. The input value is in which part of the domain? Okay, and that would be right here. So I'm going to use the f of x equals x squared minus 6. So f of 8 would be 8 squared minus 6. So f of 8 would be 64 minus 6. So what would that be? 58? So your output is 58. Let's try 0. If I put in 0, 0 would be right here. That's 0 would be an input value right there. So f of x equals x squared. That's the function that I'm going to do. So f of 0 is equal to 0 squared. Output is 0. Okay, at this time I'd like you to pause the video. So actually hit pause, and I'd like you to fill in these questions right here. Just those questions. You don't have to do the graph unless you want to do the graph for a little bit of practice. But when you unpause the video, I will have all the answers there. All right, go ahead and hit pause now. Okay, so let's see how you did. Check your answers, and remember, I'm human, so I might have thrown a mistake in there. So let me know if you see anything. Otherwise, I'd like you to try one more problem. Let's try this one right here, and what I'd like you to do, you don't have to do the graph, but I would like you to do these questions right here. So again, I'd like you to pause the video, do those real quick, and then unpause the video when you're ready to check. Okay, pause the video now. Okay, so check your answers on this one and let's see how you did. Again, you didn't have to graph it, but if you wanted a little bit of extra practice with the graph, this is what your piecewise graph would look like. Okay, you do have some practice. It will be on Teams due to copyright issues, and I wish you all the best of luck.